It's allowed me to record it. First time all morning I've been trying to record it. All right, so we're skipping the do now. We're going to start off with some basic definitions. Collinear versus non-collinear. In order for points to be considered collinear, they need to exist on the same line. So let me give you an example. Points A, B, and C are collinear points. Why are they collinear? They're points that all exist on the same line. Now, something interesting here. Here's point Q and here's point R. Technically speaking, right now, is there a line between Q and R? No, there's no line between Q and R. But it only takes 2 points to determine a line or a segment. It only takes 2 points to determine a line or segment. What does that mean? That means between any 2 points on the same plane, you can draw a line connecting them always. So even though there's not a line connecting Q and R, it is considered collinear. It is considered collinear, even though there's no line connecting them. Any 2 points are always collinear. So let's look at what non-collinear would look like. So points M, P, and T. Is there any way I could form a line connecting all 3 of those points? There's no way to form a line. These are non-collinear. But what about just M and P? Are they collinear? Yeah, just P and T are collinear. Just M and T are collinear. But M, P, and T, non-collinear. All right, we're going to skip all these questions except number 3, and we're going to take a vote right now. So it's going to be thumbs up or thumbs down, okay? Are points R and P collinear? Thumbs up if they are, thumbs down if they aren't. Thumbs up or thumb down? Thumbs up, thumb up. All right, they are collinear. Why are they collinear? Emily? Because any 2 points are always collinear because you could draw a line connecting them. All right. In order to say that a point is between 2 other points, all 3 points must be collinear. Do we agree in this diagram points A, B, and C are collinear? So because the 3 points are collinear, I am allowed to say B is between A and C. What do you think? Do you think I can say L is between M and W? Good. I see you shaking your heads no. Why no? Because M, L, and W are non-collinear. So this would not work for between. We cannot say L is between M and W. That would not work. All right, the triangle inequality theorem. The triangle inequality theorem tells us the sum of the lengths of any 2 sides of a triangle is always greater than the length of the 3rd side. Just to give you a little frame of reference here, let's say I gave you 3 pieces of spaghetti, all different lengths. The 3 pieces all had different lengths. Now, can you take those 3 pieces and put them into a shape of a triangle? Can you try? You can try. Now, will it always fit perfectly together, the 3 pieces of the spaghetti? No. There could be a gap. There could be an overlap. It doesn't mean just because you have 3 pieces of spaghetti that they'll fit perfectly together to make a triangle. So that's what this inequality theorem is telling us. It's telling us that in order for these 3 pieces of spaghetti to fit together and make a perfect looking triangle without any gaps or out any overlaps, that two lengths added together, that sum of those two lengths added together has to be bigger than the length of the third side. And as long as that criteria is met, then those pieces of spaghetti will fit together and make a triangle nicely. All right, so now I'm giving you some sample spaghetti pieces, and I'm saying, okay, well, will these fit together to make a nice triangle? Yes or no? So let's test these. So how do we test them? We take any two sides, add them together, and what does it have to be greater than? 24, the last side. Is 11 plus 14 bigger than 24? Yes. So now let's do this. 11 plus 24, is that bigger than 14? And last but not least, 14 plus 24 is definitely bigger than 11. Do you think, are these pieces going to make a nice triangle? Yes. Do you think I need to test all the sides every time? No. Which sides do you think I need to test? Bridget? Well, hypotenuse and legs are only for right triangles. But I think I know what you mean, the two smallest sides, because the hypotenuse is always biggest. So we need to try the two smallest sides and compare it to the longest side. That's all we need to test. So let's see. What are the two smallest sides here? 3 and 4. So 3 and 4, we need that to be bigger than the last side, which is 8. Is 7 bigger than 8? No. So will these pieces fit together nicely to make a triangle? No. All right, let's put a star on number C. There's definitely a question like this on your quiz on Monday. So if you've been listening to me today, I've already told you a lot of things to expect to see on Monday. All right, we want to find the restrictions on segment RT. We want to find the restrictions on segment RT. If you remember, was it last class? I think it was last class. If you remember last class, I said anytime I ask you for restrictions, how many answers do I want? How many answers do I want anytime I ask you for restrictions? Good. 2 answers. I need 2 answers. So what are the restrictions on RT? Well, this is a triangle. We need it to fit together perfectly to make a nice triangle. So what does the rule say? The rule says the two sides added together have to be what in comparison to the last side? Greater than the last side. So RT has to be less than, right? The two sides has to be bigger than the third side. So RT has to be less than 8 plus 4. So I'm going to write this out for you. Less than, subtract the two, I always say that. Less than, add the two sides. Less than, add the two sides. But that's just one part of the answer. How many answers do I need? 2. So now I need to figure out what RT is greater than. So RT is less than 12, but now I need to figure out what RT is greater than. Bridget? It has to be bigger than 8. It could be actually smaller than 8. Like if I put a 7 here, 4 plus 7 is 11. That's bigger than 8, right? So it's smaller than 8. Good. 4. How did you do that?
Well, if it was anything less than 4, it just wouldn't.
Good. Or it can't even be equal to 4, right? So if I put a 4 here, 4 plus 4 is equal to 8. The sum can't be equal to the third side. What does it have to do? It has to be greater than the third side. So how did we get 4? You take your two sides and subtract them. Take the two sides and subtract them, and that's how we get the number it has to be greater than. So RT is greater than 4. So then I'll put a star and I'll say greater than, let's do it in a different color so it stands out to you. Do pink. Greater than subtract the two sides. And you could leave it just like this. Less than box it, greater than box it, you're done. All right. Things we should and should not assume from a diagram. I'm going to keep this really simple for things that are just important for us moving forward. So I'm going to cross out 2, 3, and 4. There's really only one helpful thing that will help us in future problems that we are allowed to assume. That one thing that we are allowed to assume, that thing is straight angles. We are allowed to assume straight angles, which means if it looks like a straight angle, we can say it is a straight angle. Why is that helpful? Because straight angles are what? 180 degrees. That's why it's helpful, because straight angles are 180 degrees. All right, things we should not assume. We should not assume right angles. Just because it looks like 90 degrees does not mean that it is 90 degrees. We should not assume perpendicular lines. We should not assume parallel lines. We should not assume congruency. Just because two things look like they're congruent does not mean that they are. And I'm going to add one more thing that we should not assume. We should not assume size of angles or segments. Basically, the rule of thumb is nothing is drawn to scale. If you really understand that and realize that while you're doing every problem that nothing's drawn to scale, then you're good. Then nothing will trick you. You won't think it's a right angle because it looks like it's 90 degrees. You won't think that one segment's longer than the other just because it looks like it's longer than the other. You won't ever be tricked if you just realize that nothing is ever drawn to scale. All right, I'm going to give you a statement, and you're going to do thumbs up if we can assume it. You're going to do thumbs down if we cannot assume it. So first statement, angle ACD is a straight angle. Angle ACD is a straight angle. Thumbs up or thumbs down? Good, thumbs up. Let's write that. We can assume that angle ACD is a straight angle. All right, thumbs up or thumbs down? Angle A is a right angle. Angle A is a right angle. Excellent, thumbs down. Angle A is not a right angle. We cannot, or it could be, we just can't assume it. All right, last one. Assume or not assume? Segment AC is longer than segment CD. Segment AC is longer than segment CD. You are all rock stars. You got it. We cannot assume that. You may. Pass this up there on the filing cabinet. All right, we are going to skip number 2 for now. If we have time, we'll come back to it because I want to focus on number 3. Why do I want to focus on number 3? Because there is a system of equations on your quiz. There's a system of equations on your quiz, and this is a system of equations, so I want to practice that. So many questions I've given you. Just don't expect that all the time. All right, so here we have angle 1. Oh, sorry, what is the most important thing we do? Label. Most important thing we do is label our diagram. So angle 1 is represented by x plus 20. Angle 2 is represented by y plus 20. Angle 3 is represented by x plus 2y. Now, I already told you this was a system of equations. Can someone tell me, how do I know? How did I know this was a system of equations? Or how do we know? Only Adam? Really? All right, let me tell you, because you're going to need to be able to figure it out on your own in the future. So, do you see how I have two different variables? I have x's and y's. Anytime you have two different variables, you're going to set up a system of equations. Now, the way we set up a system of equations is we need how many different equations? Who remembers how many different? Two. We need two different equations. Not one equation that just is formatted different. Two different equations. Now, can I assume that angles 1, 2, and 3 are right angles? Can I assume they're 90 degrees? No. Did it tell us they were 90 degrees? No. There is nothing to lead us to believe that we are allowed to say that these are 90 degrees. So now we have to go by what we are allowed to assume. And really, what's the only thing we're allowed to assume?
Straight angles.
Straight angles. With that said, does anybody see two angles that make a straight angle? Not Adam, not Chase. Somebody else. Not Bridget. Olivia. 1 and 2. Perfect. Do we see this straight angle right here? Don't 1 and 2 come together to make a straight angle? Added together, they make the straight angle. So we know angle 1 plus angle 2 has to equal 180. Well, isn't angle 1 represented by x plus 20? And angle 2 is represented by y plus 20. And that's going to equal 180. Combine our like terms. We're going to have x plus y plus 40 equals 180. What do you think I'm going to do with that 40?
You're going to subtract it from 180?
Yeah, I'm going to subtract it to the other side. So it's going to be x plus y equals 140. That is our first equation. I need another one. Logan? Was it Logan? No. Yeah? Excellent. It usually takes students a little bit longer to see that one. Look at this, angle 2 and 3. Do we see that? These two angles together make a straight angle, that blue straight angle. So our second equation is going to be based on angle 2 plus angle 3 equals 180. So we are x plus 2y plus y plus 20 equals 180. Combine our like terms. We are x plus 3y plus 20 equals 180. What do you think I'm going to do with that 20? Sophie. Subtract it over. X plus 3y equals 160. That is our second equation. So now we're going to stack them up. X plus, put that on top, x plus 3y equals 160. And then below it, x plus y equals 140. Now, if I were to add these, would anything cancel? No, but what can I do?
You could, like, put one variable on one side, so, like, subtract
Oh,
y.
you want to solve through substitution?
Yeah.
Yeah, I don't want to solve through substitution. You're good, though. I just don't want to do it. What's your name? Maya. Yeah, we can distribute in a -1 right here. And that way we can cancel out. So x plus a -x cancels. 3y minus 1y is 2y. 160 minus 140 is 20. So 2y equals 20, y will equal 10. I found the y. Now what do I do? Jocelyn? Excellent. We're going to take one of our equations and substitute it in. So I'm going to go back to x plus y equals 140. 10 plus y equals 140. So, oops, I plugged in wrong. I plugged in 10 for x, not y. Sorry. X plus y equals 140. X plus 10 equals 140. So x will equal 130. What was I asking for? What was I asking for in the problem? Go back up. Sophie? Oh, good, all the angles. So I'm going to go through and I'm going to figure out what these are. So angle 1 is x plus 20. What is what is x? Isn't it 130? Yeah. 130 plus 20 is 150. All right, angle 2 is y plus 20. So that's 10 plus 20, which is 30. And angle 3, I don't have much space, I will tell you, will also be 150. You do not need to worry about anything like the independent. There will be nothing on that. We still have 6 minutes, so let's go back to number 2 that I said we'll skip. I want you all to do number 2 completely by yourselves. Do number 2 completely by yourselves. I'm going to be coming around, poking my head over your shoulder, seeing what you're doing. Most important thing is to do what? Label. Mariana, you missed this problem. I'll scroll down so you can copy it.
Thank you.
Okay. I love the labeling. Yep, number 2. Why are we equal to 0? Okay, so what kind of angle is ABC? A straight angle. Don't these two angles together make the straight angle? So what should it equal? 180, you got it. I'm not sure where I'm looking. Oh, you're still? No. All right, so I saw for most of the students, you guys labeled it really well. You had ABD is 3x plus 4, and DBC is x plus 16. Now, when you came to solve this, or you come to solve this, what kind of angle is ABC? James?
180.
A straight angle, it's 180. So what do we know about these two angles together? They have to add up to 180. This should be your equation. How many people got that, or at least were thinking that? Good. So combine your like terms. We have 4x plus 20 equals 180. 4x equals 160, so x will equal 40. But now we want to find angle ABD. How do I find angle ABD?
Substitute the 40 in for x.
Substitute the 40 in. You got it. So it's 3 plus 40 plus 4, which is going to be 124 degrees. All right, we are done.